is Mohaimin bin Osman. I am final year student of Muslim University of Malaysia Pago. I would like to present my project with PSM2, and the title for this project is The Characteristic of Pulp and Paper made from bottom section of Betong bamboo by soda piping method. Not to be forget, my guidance in this project, which is my supervisor, the Saiful Rizal bin Masrul. These studies were carried out to gain understanding for characteristics of pulp and paper made from bottom section of Dedrocalamus Asper, which is Betong bamboo, by soda piping method. 120 GSM of iron sheet were prepared from the bamboo pulp. The procedure and characteristic test had been conducted according to MSISO. I would like to start with the introduction. The paper is often used in packaging since it is biodegradable and environmentally beneficial. Paper packaging is a versatile and cost-effective method of protecting, storing, and transporting a wide range of commodities. Paper making is a series of steps that convert fiber into paper. Pulping, on the other hand, is one of the first processes in the process of manufacturing paper. Pulp and paper is one of the world's most significant sectors. Consumers of pulp and paper goods came from all walks of life. Bamboo, bagasse, rice straw, wheat straw, sorghum residue, corn straw, and wheat are examples of raw sources in making non-wooden paper. Pulping often uses some chemical during cooking, such as sodium hydroxide and soda pulping, which invented in England. Bamboo and other non-wood fibers have played a major part in the pulp and paper industry worldwide. Bamboo is regarded as a viable alternative to wood due to its superior physical and mechanical properties. Bamboo grows faster than trees and begin to produce after just 4 to 5 years. They can be harvested selectively and non-destructively once a year. The objective of the study will produce soda pulp and paper making from bottom section of Betong bamboo, and observe the bottom section of Betong bamboo soda pulp and paper physical and mechanical characteristics. For the literature, Dedrocalamus asper is the gigantic tropical and subtropical dense clumping species native to Southeast Asia. Due to its large gum size, Betong bamboo is one of the species with the greatest potential for board manufacture. It can reach a height of 30 meters and have a diameter of roughly 20 centimeters at the bottom. The chemical component of bamboo cell wall include cellulose, hemicellulose, and lignin. The chemical composition of straight bamboo has been developed in the first table. The term polycellulose refers to fiber carbohydrate content, which include alpha cellulose. Straight bamboo has a lignin concentration of 28.7%, which is comparable to softwood. Internal holocellulose content was somewhat higher than non-holocellulose content, while non-lignin content was greater than internal lignin content. For fiber morphology is an essential feature in the pulp and paper industry for producing high quality of pulp. This is because the fiber material has an impact on the ultimate quality product. Fiber length, fiber diameter, lumen diameter, and cell wall thickness are some of the most essential features in fiber morphology. The morphology for Betong bamboo was shown in the second table. The fiber length is 2,928 micrometer. Fiber diameter is 23 micrometer. Fiber lumen diameter is 6.5 micrometer, and fiber wall thickness is 9 micrometer. This table shows Betong bamboo has high fiber morphology. In the methodology, the flowchart shows the flow of the thesis was complete. The preparation for the material had been done completely. Betong bamboo was used as raw material. It was collected at Johor in Malaysia. The bottom bamboo section was cut with a chainsaw machine. The bamboo was chipped into smaller pieces as 3 multiplied to 5 millimeters using chisel and hammer. The bamboo skin was detached and the bamboo chips were sun-dried for 3 days to ensure that the bamboo was properly dry before oven dry. In soda piping, the bamboo chips were pulped in digester with 25% of active alkali concentration and cooking temperature of 170 degrees Celsius. For bamboo pulping, the fixed parameter was 60 minutes to reach the pulping temperature and 3 hours at pumping and temperature, and 7 to 1 liquid to bamboo ratio. After the digesting process was complete, the pulp was distilled in hydrocarbon for 10 minutes to eliminate any leftover black liquor. The skinning procedure was then carried out. After that, excess water was removed with a pulp washing centrifugal, and the skin pulp was distributed with a Hobart mixer. Finally, the bamboo soda pulp was wrapped in plastic bag and kept cool in chiller for processing and analysis. For the process in handshake making, 42 gram oven-dried weight of Betong bamboo soda pulp were disintegrated for 15,000 revolutions to disperse the pulp with the addition of 2,000 ml of water into the instigator tank. After completion, the instigated pulp from the distillating tank was poured into the stock divider. The water level inside the stock divider was raised up to 14 liters level. The fitness test was performed using 2 liters of pulp. To achieve a basis weight of 120 GSM, 2 liters pulp were used in correction test to check the weight of the paper sheet. After the correction test was performed on the stock preparation, the process continued with the preparation of 12 paper sheets by the handshake machine. After completion, between the sheet, 2 dry Reuters paper were inserted. The stacked handsheet were pressed approximately at 345 kPa in order to remove the residual water content. The pressing procedure was repeated for another session with the same pressure after changing the butter paper between the sheets. Each plate was placed in drying ring with its test sheet attached. Every ring was firmly squeezed together to verify that they were in contact. Finally, for 24 hours, the drying was placed in a controlled room temperature. The characteristic tests were conducted according to Malaysia's standard method, which is MSSO, for physical and mechanical properties include scanning electron microscope, which is SEM. In the result, for physical properties, 5 samples were used to measure the thickness of paper and 5 locations were measured to obtain the thickness. Single paper sheet have an average thickness of 408.2 meter. The gauge value was 134.5 GSM, which is almost similar to the real value that is 120 GSM. The apparent density is 0.0307 gram per centimeter cube. For mechanical properties, the average potential strength and tensile index is 4.17 kN per meter and 33.52 Nm per gram. Tearing is the amount of paper elongation that occurs when a specific force is applied to the paper, as well as the amount of strain required to break the paper at a specific distance. The tear index of Betong bamboo paper is 2.156 mm square per gram, with an average tearing of 268.44 mm per sheet. The density is related to the length and thickness of the fiber, which reduces tearing resistance. Burst index measures the perpendicular pressure of paper that able to resist before the paper rupture. The bursting test average is 212.8 kilopascal and the bursting index is 1.709 kilopascal meter square per gram. Bursting strength was depend on interfiber bonding. The folding test was measured to testing the capability of the paper withstand multiple fold before it crashed, and also to measure the duration of the paper. The number of double folding sheet is 14, while the folding endurance mean is 1.15 C. The table shows the comparative characteristic of Betong bamboo paper characteristic with another type of paper report by previous study. It can be seen that the mechanical properties of other bamboo papers were different with Betong bamboo result. The comparison below demonstrates the range of bamboo in tensile index, tip index, burst index, and double folding. The tensile index for Betong bamboo is greater because the fiber strength quality very depend on the individual fiber strength. However, Betong bamboo has the lowest tear index. It occurred due to the bamboo age, as the age was high and the tear index was low. This index has the same amount as other bamboos because of its strong fiber strength. Betong bamboo paper had much higher folding endurance than other bamboo paper. In SEM, the weight of the paper and bamboo fiber was determined using a SEM equipment. The high voltage value used for all tests is set at 20 kilovolt. The structures views of bamboo fiber through a 500 magnifying lens. The fiber has a vast surface area and the Betong bamboo fiber width is 24.5 micrometer. The second figure illustrates that the fiber is curved and has a width of 12.4 to 32.3 micrometer when zoomed in 300 using a magnifying lens. In conclusion, the study's goal has been met with success. Betong bamboo can be successfully pulped according to the study. The bamboo paper outperformed the past study in terms of textile index, tip index, burst index, and folding qualities. It demonstrates that the paper qualities of Betong bamboo different from those of sweet bamboo and mountain bamboo. The bottom section of Betong bamboo has the potential to be used as a key raw material in the paper making industry because it has the same quality as standard paper. However, there are still several areas that may be improved in order to produce a higher quality document. These are the references that were used in completing this project. Thank you for lending your eyes and ears. Thank you.